Objective 2.5, Dividing Polynomials. So a couple of lessons ago we talked about the other operations with polynomials, adding, subtracting, and multiplying. And now today we want to talk about the fourth operation, which is being able to divide polynomials. Now, since our last lesson was a fairly long one, the good news is this one's going to be fairly short to kind of even things out. So let's get to it. So our objective for this lesson is to be able to divide polynomials using two different methods, long division and synthetic division. So our vocabulary box tells us today that in long polynomial division, when you divide a polynomial f of x by a divisor d of x, you get a quotient polynomial q of x and a remainder polynomial r of x. So you notice here that each piece of this problem is a type of function. So our dividend, the original polynomial, is our f of x. Our divisor that we're going to divide by is d of x. The quotient answer that we get is q of x. And the remainder is r of x. And we can put those pieces together into a statement that says that when I take f of x and divide it by d of x, I get q of x as an answer plus the fraction form for my remainder. So taking the remainder r of x over the d of x, putting that in fraction form. It goes on to say that according to the remainder theorem, if the polynomial f of x is divided by a particular divisor that's in that form of x minus k, then the remainder r is equal to f of k. Okay, we'll see what that all means in just a minute, but this actually ties back to what we were talking about when we did synthetic substitution. When we were trying to find f of k, we could use the k value and synthetic substitution to find out what the answer was. Okay, well, we can use that same process, but our k is going to come from the divisor that's in x minus k form. Okay, and then that's called synthetic division. So synthetic substitution gives way to something called synthetic division, which is kind of a shortcut for division. And it only works when our divisor is in that x minus k form. Okay, and so it's the k value that we're interested in for setting up the synthetic division, looking to see what the remainder is going to be, and using that to figure out what our quotient and what our final answer to the division problem should be. All right, so let's see how all of that fits together. So in our first example, we want to divide x to the fourth minus 3x cubed minus 2x plus 1 by x squared plus 1. So notice here that this polynomial that we want to divide by is not in x minus k form. We've got a squared here, and so it's not in this form. Okay, so that means our only option here is to do this division by long division. Long division with polynomials is very much like what we do in long division for numbers. And I would suggest that if you ever get stuck in doing these problems, that you actually think about what would I do if this was just numbers at this point. And it's probably going to be very similar and could help you get unstuck. So let's start by setting this up. We're going to put our x to the fourth minus 3x cubed minus 2x plus 1 inside of our bracket, and the x squared plus 1 outside of our bracket, because the x squared plus 1 is our divisor. It is what we are dividing by, and divisors always go on the outside. The polynomial that's on the inside is called the dividend. And we always want both our divisor and our dividend to be written in standard form. But especially in our dividend, we also want all terms to be accounted for from the highest degree down to the constant. So you'll notice in this case, the original polynomial did not have an x squared term. But when we set it up in the bracket, we have added a 0x squared term in the polynomial. So it's acting as a bit of a placeholder. 0 times x squared doesn't change the original polynomial, but it does give us a place to put x squared terms. Okay? So you want to watch for that. If you ever have a missing term, you're going to want to add it in when you set things up using a coefficient of 0. All right, so for the actual multiplication, or excuse me, the actual division, we start just by looking at the first term in our divisor and asking ourselves, what do I need to multiply by in order for it to equal the first term in our dividend? Now this is one place where polynomials are a little bit different than numbers. With numbers, we would just want to maybe use the first 1 or 2 digits and try to divide into the dividend to get as close as we can without going over. So we're not trying to get things exact with numbers. With polynomials, though, we have to get things exact, but only with these first terms. So it's only this first term here and this first term here that we have to worry about getting exactly. Okay, so what do we multiply x squared by to get x to the fourth? Hang on just a second, guys. I'm going to get rid of this little message here, so it's going to go away for a second. There we go. All right, so what are we going to have to multiply by? We're going to have to multiply by an x squared. And when I do that, when I decide that this is my x squared, this is what I need up here, I'm going to line it up so that like terms are all lined up. That's why I wanted the 0x squared there in my dividend. So I have a place to line up all the x squared terms. Okay? And then I take that x squared times everything in the divisor. So it's not just the first term anymore, it's the whole thing. So x squared times x squared gives me x to the fourth, and x squared times 1 gives me x squared. And then just like with numbers, once I take this piece times my divisor, I'm going to subtract that result. Okay? Now, here again, I would really recommend that instead of dealing with it as subtraction, that you're going to change this into adding the opposite. Because your brain generally tends to want to add things. And so if we leave it as subtraction, by the time you get over to your x squareds here, there's a good chance you're going to forget that you're subtracting and you're going to end up adding, which is going to mess up your answer. So we're going to help our brain out a little bit, and we're going to change this to adding the opposite, so that then all of my terms are ready to be added with the correct sign, and it'll make my brain happy. It'll do what it wants to do. So when I take the x to the fourth plus the negative x to the fourth, I'm going to get nothing, which is exactly what we want. That's why we have to get this to be exact, because we want these to cancel out. And then since there's no term here, that literally means negative 3x cubed minus, or plus, excuse me, plus 0. So I'm going to keep a negative 3x cubed. Here I'm going to take the 0x squared, add a negative x squared, and get negative x squared. And then, just like with numbers, I bring down my next term. Okay? And then I just repeat the process all over again. So now I want to know, what can I multiply my x squared by to get me negative 3x cubed? Okay, so again, that initial decision of what to put up here just comes from leading terms. Once I decide what to put up there, which in this case is going to be negative 3x, then I do the multiplication with the entire divisor. So taking negative 3x times x squared plus 1 gives me a negative 3x cubed and a negative 3x. And again, look at how I am lining up all of the like terms together so that I don't mix things up. Now again, I'm supposed to subtract this result, but I'm going to make my life easier and change it to adding the opposites. And so now the negative 3x cubed plus the positive 3x cubed is going to give me 0. The negative x squared with nothing will stay negative x squared. And the negative 2x plus 3x will give me an x. Okay? Go through the process one more time. Now I'm looking at, what do I multiply x squared by in order to get negative x squared? And that answer is going to be a negative 1. So now I take the negative 1 times x squared plus 1, subtract that, but actually add the opposite, and then I end up with x plus 2. My x squareds cancel, the x comes down, and 1 plus 1 gives me 2. Now, at this point, I have gotten to a remainder. Okay? How do I know when I'm at a remainder? This will be a remainder if the degree of remainder is less than the degree of your divisor. We should call this r of x. Okay? So since my divisor was an x squared, but my remainder here is just an x, that's how I know that I can't go any further, and x minus 2 is going to be my, x plus 2 is going to be my remainder. And again, just like with numbers, in numbers we have a few different ways we can deal with remainders. In polynomials, only one of those makes sense. And the one that makes sense is to take that x plus 2, put it over the divisor, and make a fraction out of it. So I have the x squared minus 3x minus 1. That's the quotient part from our definition. And then we're adding to that an x plus 2 over x squared plus 1. That's the remainder part. Okay? And that's the answer that we get. All right, why don't you try one quick? Again, pause the video for a moment, work this out using long division, answer your Zaption question off to the side, and then come back when you're ready to check your answer. All right, so this is what it should look like. If we take x cubed plus 0x squared, don't forget to put in that placeholder, minus 10x minus 24, and divide that by x minus 3, we should end up with x squared plus 3x minus 1. If you did not get that, you might want to pause the video for a moment, go back and check your answer, see if you can find your mistake, maybe even go back and look at the actual example again and see if you can fix your mistake. All right, now in example 2, we want to take a look at this shortcut method called synthetic division. Synthetic division is based on synthetic substitution and the remainder theorem. The remainder theorem says if a polynomial f of x is divided by x minus k, then the remainder is r equal to f of k. So we're combining what we already were doing with synthetic substitution and what this remainder theorem says is going to happen. The one thing that has to be true when you're doing synthetic division is that your divisor has to be in the form of x minus k. Now keep in mind that could mean x plus something, because then we could say that that something was negative. Okay, so x plus a number or x minus a number is fine, but we can't have any x squareds, we can't have any coefficients in front of x. And so whatever that k value is, that's what we use to substitute into the polynomial to find out what the remainder is going to be. So let's see how that works. Here I have the polynomial x cubed minus 10x minus 24 being divided by x minus 3. So in the first row, I am simply putting the coefficients from each of my terms. So x cubed technically has a coefficient of 1. The next spot would need to be the x squared spot. Since I don't have an x squared, that's going to be 0. Then I have the x spot, which has a coefficient of negative 10. And then my constant here is this negative 24. And if my divisor has to be in x minus k form, and k is what has to go out here, then that's going to be that 3. Okay? So now I'm going to go through the process of synthetic substitution. So just like we were doing the couple of lessons ago, I'm going to bring down the 1 and then multiply, add my column, multiply, add my column, multiply, add my column. Now when we were doing this as substitution, we were only interested in the negative 27 because that was the answer. But now that we're doing this as division, we're interested in everything in that last row. So the last row is giving us our quotient, which is 1 degree less than the dividend we started with. So in this case, our dividend was an x cubed. That means our quotient is going to be an x squared. It's 1 degree less. The numbers, all except for the last number, give us the coefficients of the descending terms of the quotient. So we now know it's an x squared quotient, and we know 1, 3, and negative 1 have to be the coefficients. The negative 27 is our remainder. And so just like we did with our remainder in the long division, that remainder is going to go over our divisor in our final answer. So our final answer is x squared, because this one is the coefficient on x squared, plus 3x, because that 3 has to go on the x term, minus 1, because that negative 1 is going to be our constant, and then plus a negative 27 over the x minus 3 to give us the fraction. Which, if you notice, this is the same problem you did in the guided practice, and this is the same exact answer that you got. So it does work as long as your divisor is in x minus k form. Okay? All right, why don't you try one quick? Try to set it up using the synthetic division method. Answer the question on Zaption, come back when you're ready to check, and we'll finish up this lesson. All right, so if we set up this problem, we're setting up coefficients of 3, negative 2, negative 8, and 5. We have no missing terms this time, so we don't have to put in any zeros. Our k is going to be the positive 1, because x minus k means k would have had to be 1. And then we're going to do our synthetic substitution. So there's 3, multiply to get 3, 1, 1, negative 7, negative 7, negative 2. Okay, so from that, we can come up with our answer, which is x squared, 1 degree less, minus x minus 9 equal to negative 4 over x minus 1. That's not what I said, was it? Let's try that again. So 1, negative 2, negative 8, 5. 1 out here. So there's 1, 1, negative 1, negative 1, negative 9, negative 9, negative 4. There we go. I'm not sure what mistake I made before, but that's what it should be. That's what it should look like. And so there's our 1, there's our negative 1, there's our negative 9, and there's the negative 4 as the remainder. All right, so that's it for this lesson. Your problems in your objective are simply going to be problems that you have to use the different types of division on, and that's it. That's all you'll be practicing with this lesson. So seek out the resources you need if you have any questions. Make sure you answer or check your answers with the answers posted on Canvas, and let me know if you have any questions or problems with this lesson. And that's it for 2.5. We'll see you next time.